Another type of force which is called as spring force. Another type of force which is called as spring force. Are you able to see the screen?
Yes, sir.
Okay. Can now see here first force. Okay. So until now we discussed about okay, in Newton's laws we discussed first the three laws. Okay, first law, second law, and third law, and then afterwards we have seen types of forces. Correct? What are the different types of forces? What is the first force we learned? What is the first force we learned?
Gravitational force.
Next, second force.
Normal reaction.
Correct. Normal reaction force. And what about third force?
Tensional force, sir.
Correct. So yesterday we have seen how to find out tension in heavy ropes. Okay. Now last force which we are going to see is called as spring force. Very, very important. And after that we have one more topic called as inertial frame and non-inertial frame. Inertial frame and non-inertial frame. Inertial frame and non-inertial frame. In this we are going to see one more force that is called as pseudo force. In this we are going to see one more force called as pseudo force. Okay, so we have finished this one, this one, this one. So now today we are going to see spring force. Okay, now you know you must have seen springs, correct or not? You must have seen springs. Okay, so suppose let us say there is a spring here like this. Okay, now this spring, if you compress, that means if you apply force like this, what will happen? What will happen? If you apply force like this, what will happen? What will happen to spring?
So it would get compressed.
Okay. If I reverse the direction?
Relaxed.
Not relaxed, elongated.
It would expand.
Expand or elongation, correct? Or elongation, correct or not? Okay. So that means if I apply force like this, that is called as compressed spring. If I apply force like this, that is called as what? Relaxed. Sorry, not relaxed. Elongation. So this is called as spring in compression. This is called as compressed spring. This is called as compressed spring. And this is called as what? Elongated spring. This is called as elongated spring. And this is a spring in natural length position or relaxed spring in natural length position. Spring in natural length position, or we can also say it as relaxed. Spring is relaxed. Okay. So this and there will be particular length when it is relaxed, that is called as natural length. This x naught is called as natural length, maybe 1 centimeter, 2 centimeters like that. This is called as natural length. Okay, and when you compress, the length will decrease. When you elongate, the length will increase. Okay, so now let's see. Okay, and generally we consider ideal springs. Just like we have taken massless strings, massless pulleys like that. Here also we consider ideal springs, which means mass is approximated to 0. Practically there is no spring which has mass 0. Okay, every spring will have some mass, but we consider it as almost 0. Okay, so there is no gravitational force for spring. Okay, so now let us see some important properties regarding spring force. Okay, suppose let us say there is a wall like this. Okay, and then we have connected a spring, okay, and the spring is connected to a block, okay, and now the spring is under natural length position. This position is called as natural lengths, okay. This position is called NL, means natural length position, okay. Now what I'll do is, okay, now what I'll do is I'll apply force like this. I'll apply force like this. Now what will happen to spring? Tell me. What will happen to spring? Compression or elongation?
Elongation.
Elongate.
Okay. So I have elongated like this. Okay. Now I released. Now I release the block. What will happen? Now I release the block. I moved
So
certain
it will
distance.
get compressed.
No, in which direction the block will move?
Towards left side.
Towards left side. Okay. So now who is? I am not pushing. No? I am not pushing the block left side. Who is pushing?
Spring.
Who is making the block to move left side?
So
Who is
The other end
this
of the
force
spring.
of the spring.
spring? Correct. This end of the spring is making the block to move left side. So this force is called as what? This force is called as what? Spring force.
Spring force.
Understood? Okay. Now, when the spring is at natural length, is there spring force here? Is the block moving left side now, right now?
No, sir.
So that means spring force here is how much?
0.
0. So this is the first property. What is the first property? When the spring is in natural length position, spring doesn't apply any force in spring doesn't apply any force, apply no force in what? In which position? In which position?
Natural length.
Natural length position. Okay. Next, second one. Now see here. Now, but whereas when the spring is either elongated or compressed, correct or not? Okay, compressed also it will do. I'll explain. So now what happened here? The spring is now when you move the block to right side and leave it, the block is moving left side because of spring. Okay. Now this is spring. Okay, the other end here, which is connected to wall. Now here also the spring will apply the force on this wall. Okay, if you want to visualize, instead of wall, suppose let us say instead of wall, okay, you keep some plastic material, some elastic material. Now when you what you call move the block right side and leave it, what will happen to this elastic material? It will bend like this, correct or not? It will bend. Okay, who is making to bend? Spring force. So that means this spring force will apply force at both ends. Very important. Okay, so that is the second property. What is the second property? Spring applies force at what? At both ends, and magnitude is equal. And magnitude is what? Equal. Only direction is different. Here direction is which side? This end. What is the direction at this end? Direction at this end?
Left side, sir.
Left side. And the other end?
Right side.
Right side.
Right side. Hello. Good morning. Sir. Okay. So second point you have understood, spring applies force at both ends and magnitude is equal. Okay, but opposite in direction. Okay, and it is even true in this case also. Okay, for example, let us say I compress the spring like this. Okay. Now I push the spring left side. So now, and if I leave it here, what will happen? Tell me. If I leave it here, what will happen? What will happen to block? What will happen to block? What will happen to block? Did you understand my
Sir,
question?
can you repeat the question?
Question is from natural length, I push the block left side like this. I pushed it like this, or I compressed the spring like this. I compressed the spring like this. Now I released. Now after compressing, I released. What will happen now to the block?
Sir, it will
Sir, it will come back.
It will move which side? The block will move which side?
Right side.
Right. Who is making the block move right side? I am not there.
Spring force.
Spring force. So that means the direction of spring force at this end is which side?
Right side.
And what about other end?
Left side.
Left. Okay. Is it clear? Okay. So see this is in elongation you see the direction of spring force, and in compression you see the direction of spring force. Okay. One way is just by common sense. Okay. When you elongate and leave it, it will move this side. So by that visualization you can say, and when you compress it like this and then leave it, it will move this side. Like that you can visualize. Otherwise, if you want to know the direction of spring, okay, this is a very, very important property. Okay, this is a very, very important property. Spring applies force. Spring applies force in a direction. Spring applies force in a direction so as to regain its natural length. Its natural length. Now see in this first case, elongation case. Okay, when I release, okay, natural length is up to green color only, na? Correct or not? Okay, so when I release this block at this point connected to spring, now spring is applying force which side here at this point? Left side. That means it want to come to natural length position. See here. Same way this end also, you see, it want to come to natural length position. This same way here also, when you compress the spring with the block. Now when you release it, now natural length is here, na? So it want to come this side. So therefore it will come like this one. And then this is what you call other end will always be opposite direction. Are you understanding? So therefore this property is very important. Spring applies force in a direction so as to regain its natural length. So direction is over. So in which direction it will apply force, I already told. Next one is the magnitude of force. What is the value of this spring force? Okay. So for that, suppose let us say, okay, I elongated the spring like this. I elongated the spring like this. Okay. And let us say the length from the natural length position is delta x. Okay. So this is called as elongation. This is called as what? This is called as elongation. Okay. Always remember this is called as elongation. Okay. So now what is the force exerted? Now spring force direction is which side here at this point? In which direction the spring force will be? Left or right? Left or right?
Right.
At here. Spring force.
Left, sir.
Left, na? Spring force is left.
Yes, sir.
So what is the magnitude of that spring force is given by Fs is equal to K times of delta x. Fs is equal to what? K times of delta x. Fs is equal to K times of delta x. Very, very important formula where K is called as a spring constant, where K is called as spring constant, and delta x is called as elongation or compression. Elongation or compression. For example, let us say you compress the spring like this. Let us say you compress the spring like this by delta x, like this. You are compressed by how much? Tell me. You are compressed by how much? Delta x. Now what is the spring force at this point direction? Tell me, what is the direction of spring force at this point? Which side it will be? What is the direction of spring force?
Sir, right side.
Right side. That is Fs. How much is this Fs? What is the value?
K delta X.
K into delta X. What is K?
Spring constant, sir.
And delta X is called as?
Compression in this case, or it can be even elongation.
Correct. Okay. And here 2 points are there regarding delta X. Don't, okay, just write only magnitude. Okay. Second point is it is always measured from natural length. Always measured from what? Always measured from what? Always measured from where? See, always measured from where?
Natural length.
Natural. Okay, so this is regarding spring force. I hope you understood. Okay, so properties. First property, spring doesn't apply any force in natural length position. Second one, spring applies force at both ends and magnitude is equal. Third property, spring applies force in a direction so as to regain its natural length. Okay, and then last one is the magnitude of the force. Okay, so now I'll explain what is the spring constant mean by. Okay, let us take one simple example. Here there is a wall. Okay, and then to this there are two springs connected to two blocks. Okay, and this is the natural length position. Okay, now the spring constant for one spring is 500, spring constant for other spring is 1000. Find the force required to pull the springs by 1 centimeter. Okay, so that means how much force is required to pull the springs by 1 centimeter. Okay, now let us see. Suppose let us say this one. Okay, let us say this is the natural length position, correct? Like this. Now first spring I elongated like this. Okay, second spring also I elongated like this. In both cases my elongation is how much? Delta X is how much? 1
centimeter.
This is also okay. Now what is the force required to pull? That means here man is there who is applying force like this. Here also man is there. If suppose man is not there, suppose let us say if man has moved up to here 1 centimeter, happen will if the man
It will move right side and get compressed.
brings up to point and leaves, it will move left side, na? Block will move left side or not?
Side, sir.
Left side. Okay. So that means if the block has to stay here at 1 centimeter, man has to apply force. Some force he has to apply. Correct or not? Okay. So how much force a man has to apply? That is what. Find the force required. Okay. So now let us see. Now here, what is the direction of spring force? Left or right?
Left.
Left. Now the block is at what now?
Rest.
Rest means what? F net is
0.
So that means right side force must be equal to left side force. F applied by man. This is F applied by man must be equal to spring force. And what is the spring force? Magnitude. Just now I told.
K delta X, sir.
Correct. K into delta X, where K is called as spring constant, delta X is called as elongation. Correct? Okay. Now here in both cases, is the force applied by man same?
No, sir.
No. Why? Because
Spring constant
The
is
K
different.
values are different.
correct. So in the first case, what is the force applied by man? K1 into delta x. What is K1? 500. What is delta x?
5.
1 centimeter means 1 by 100. So that means 5 newtons. In second case, what is the force applied by man? K2 into delta x. What is K2? 1000. What is delta x? 1 centimeter. So that means how much? 10 newtons.
10.
Now see here, you have moved to the same distance, but in first case you have to apply only how much? 5 newtons. In the second case you have to apply what? More force, correct or not? Okay. Why you have to apply more force? Because of this property that spring constant is what? More. Okay. So very important point that if K is more, it is very difficult to elongate because you have to apply more force. It is very difficult to what? Elongate. If K is less, then it is easy to elongate. Okay, like for example, I'll give some examples. You must have seen some scooter keys. Scooter keys, they'll have some key, what you call springs. You must have seen, no? Correct? Scooter keys will have some springs, correct? They're very easy to elongate because for them K is what? Less. But a scooter, what you call stand is there, na? Side stand. Side stand also will have one spring. Have you observed?
Yes, sir.
Okay. Do you all know how to ride scooter? All of you?
Sir, cycle, not scooter.
Cycle only. Huh? Scooter you don't know.
They're not 18.
Achha, okay. So in a scooter, side stand will be there, and you have to, for that there will be one spring. Is very difficult. Not very difficult, but it's tight. It will be very tight. Okay. So that's called tight spring, whereas this one is called loose spring. Okay. Even what you call landline phone will be there, no? Okay. There also one type of spring will be there, correct? So that is very easy to elongate. Okay. But there are some springs which are very difficult to elongate. Okay. So that is about what you call spring constant. If K is more, it means that it is very difficult to elongate. If K is less, it is easy to elongate. Okay. Okay. Next, let us do one more problem. Find elongation in spring. Okay. Now here we are going to see vertical springs. Until now we discussed the horizontal springs. Okay. These are horizontal springs. Now we are going to see vertical springs. Find elongation in spring. Now see here. Suppose let's say this is a ceiling. Okay, to this ceiling there is a spring. Okay, whose spring constant you can take it as some K is equal to 100. Spring constant K equal to 100. And now to the other end there is a block of 5 kg is connected. Okay, now the spring is under natural length position like this. This is the natural length position. Okay, so that means a man is holding like this. A man is holding like this. Okay. Now, if the man, now here man is holding right now. Man is holding. The block is connected to spring and the man is holding. Now, will there be any spring force? Tell me now. Just think carefully. Will there be any spring force?
No, sir.
No force. Why?
Because the man is giving opposite like force.
No. First property is what?
So man is not pulling or pushing.
Ah, correct. Man is neither pulling or pushing, just is holding.
Spring in natural length, no force will
Correct.
be there.
Spring doesn't apply any force in
Natural length.
Natural length.
Right now the spring is in which position?
Natural length.
Natural length position. Okay, so therefore it doesn't apply. Okay, now now man is holding it. Okay, now man releases. Now what will happen to the block?
Elongation.
Elongation. So what is that elongation? That means it will elongate like this. Correct? 5 kg. This length is called as what? Elongation. Finally it will come to rest at one point, now like this. Okay, so what is this delta x they're asking? Okay, so to solve any problem, only one step, draw the free body diagram. That's all. This is the heart of Newton's laws. If you know how to draw free body diagram, it's over. So tell me, what is the first force free body diagram of block? Tell me, what is the first force?
Gravitational force.
How much?
50 Newton.
What else force is acting on block?
Tensional force.
Spring force, sir.
Spring force. Which side at this point?
Downward.
Spring force to know direction. What I told. Third point.
It applies force in
To come
direction
back
so as
for
to
a
regain its
normal.
natural length.
Now natural length is where? Here.
So it will go upward.
So upwards,
This one also, this end will go down.
downwards.
That is the easiest way. Okay. Are you understanding? So now the block is at rest. Okay. Tell me.
So
what
Fs is 50.
That's all. Fs is equal to what? 50. What is Fs?
Spring force.
How much?
K delta x.
K is given as how much?
100.
100.
Delta x equal to 50. So what is delta x? 50 by 100. That means how much? 0.5.
0.5 meters.
Easy or difficult?
Easy only.
Okay. If it is easy, do this problem. Okay. Okay, see here. This is a ground. There is a spring like this. Okay. There is a spring like this, which is in natural position like this. This is the natural length. That means, will there be any spring force here?
No, sir.
No, sir.
Now what I'm doing is I am applying a force. I'm putting a block of mass 2 kg on the spring. What will happen to spring?
So it will elongate.
Compress.
Compress. Now how it will elongate? How it can go upward?
It is attached to the ground.
Oh, this spring is attached to ground, na, here. And on the
Yes,
top of
okay,
the spring, we are placing what? 1 kg block. Suppose let us say suppose let's say some heavy load is put on your head, you will be compressed or elongated?
compressed only, sir.
Compressed. Okay, so finally it will be compressed and come to rest at one point like this. Correct? So this length is called as what? What is this length called as?
Delta x.
What is that?
Delta x.
What is that name? What is the name?
Elongation or compression.
No, elongation means when the spring is elongated. Here,
Sir, compression.
Compression.
Sir, compression.
Find the compression delta x. Please do it.
Sir, no K value.
K value you take as 1000. How much? What is the way to solve?
Sir, doing, sir.
Draw the FBD of block, and the block is at rest.
Sir, 0.02 meter.
Yes, 0.02 meters.
Correct. Why? Because at this point, what are the forces? First force is
So
what?
gravitational force
Gravitational
20.
force.
Spring force?
And spring force is upwards.
Correct. Very good.
Upward.
And block is
So
at?
it will be 20. Rest.
So
Rest.
Fs is equal to 20. So Fs is what? K into delta x. What is K? 1000.
1000.
Delta x equal to 20. So delta x equal to 0.02 meters. See here, very less, na? Why it is less? Spring constant is what?
Because the
very large. Okay, so therefore it's very difficult. Okay, next one. In a similar way, now find elongation. Next problem. Find elongation in both springs. Blocks are at rest. Okay. See here. Actually, these are given in the final position. Okay. Originally they may be like this. Okay. Originally they may be like this. That will not be given in the problem. I'm just telling for your case. Originally, maybe let us say this is first spring. This is the natural length of the spring, and then this 5 kg is connected, and then that means somebody must hold. Okay, then another next spring, and then 2 kg is there. This is the natural length of spring. Some persons are holding. If they don't hold, what will happen? The spring will
get elongated.
Elongated. So now 2 persons are holding like this. Now they released. What will happen when they release?
Elongation.
Elongation like this. Correct or not? Both will elongate or not?
Yes, sir.
Yes, sir.
This is 5. This is what? 2. Okay. So this is what is given to you. I hope you understood. So what is the elongation in both the springs? Now these two are at rest. Are you able to understand?
Yes, sir.
So now can you calculate? Spring constants take as this one K1 equal
Sir,
to.
do we need to calculate both differently or as a system?
What?
Both differently we should calculate or as a system?
No, differently. Just to draw the free body diagram of 2 kg. Now they are at rest. Correct or not? Okay. Draw the free body diagram of 2 kg. Draw the free body diagram of 5 kg. That's it. And spring constants I gave you. Top spring is 200. Bottom spring is 100. Do it.
So the top spring with 5 kg is 0.25 and 2 kg one is 0.2.
0.2. Okay, let us see. First, what I have to do? Draw the free body diagram of this one. 2K. What are the forces?
Gravitational force.
How much? 20. Spring force. At this point, spring force will be which side? Up or down?
Upwards.
Upwards. Let us say that is FS1. Sorry, this one is K2, no? Okay. FS2 you take. Now this is at what?
Rest.
That means
FS2 is 20.
F is equal to 20.
what is FS?
20.
Correct. What is K2?
100.
100.
So that means delta x2 is what?
0.2.
0.2 meters.
0.2.
Okay. Now tell me what is the free body diagram of 5 kg? Tell me first force is what?
Gravitational force 50 Newton.
Now this block has 2 springs. See here. Now what is the direction of force, spring force at this point? At this point.
So downwards.
Correct. Very good. How much is that? FS2, na? Correct?
0.2 meter.
FS2 is 20 newtons anyway. Okay, anyway, value is FS2. Tell me what about the direction of spring force at this point? Top spring further.
Upward.
Upwards, sir.
Upwards. That is, let us say FS1. Now this block is at what?
Rest.
That means upward force must be equal to downward force. Downward forces are how many? 50 plus
50 plus FS2.
FS2 is nothing but how much? 20 only. No?
20.
So that means 50 plus
20.
20. How much? 7. Now what is the formula for Fs? K1 into delta x1, first spring. K1 is already known. What is K1 given? 200. 200 into delta x1 is what? 70. So this implies delta
0.35.
7 by 20. Easy or difficult?
Should be careful, sir.
Easy only, so we have to be careful.
No, just only one formula, K delta x and directions. Only presence of mind, that's all. Means we just have to, first we have to learn and then apply those with the presence of mind. Okay, in this situation, which direction? In this situation, which direction? That only directions matter, that's all. Because when spring is there, we know spring force. When rope is there, there will be tension. That's all. And when there is contact, there will be normal reaction. That's all. Only thing is we just have to know directions and vectors. That's all. Vector sum. Okay. Now next, let us see one more problem. Okay. Do this problem. There is a wall here. Okay. To this wall, there is a string rope, massless rope only. There is no mass. To this, there is a 5 kg block. And then to this 5 kg block, there is a spring which is connected, whose spring constant is 100. Now, finally, the block is at rest. So what is the elongation? Delta x. And what is the tension in the string T? Now here, when they are asking elongation means automatically this spring is in which state? Is compressed state or relaxed state or elongated state?
Natural length.
No, elongation they are asking means which state is it?
Elongated.
Elongated state. Na? If it is a relaxed state or natural length, what will be the? Will there be any delta x here? Delta x is how much here in relaxed state? 0, na? Correct or not?
Sir.
So it is not relaxed. It is not at natural length. It is what? Elongated. Okay. Can you try? Can you try? Only draw the free body diagram of block. And if the forces are not in either x or y, resolve. and apply what? F net equal to MA. That's all. Only 3 steps, no?
Sir, can you tell once more what is the T? Is it?
T means tension. Tension in the
It's a
string.
rope.
Rope.
Okay.
Tension will be there only for strings, no?
Yes, sir.
How much?
2, sir.
Bhavya Yashasvi, what happened yesterday? You didn't come for class?
Sir, her net is like net connection is there problem, so she can't speak is what she told.
Okay. So something she has put in chat. Okay. How much?
Sir, I don't know if it is correct. I got FS as 0.5 and TS 50.5.
Now delta x, how much you got?
So delta X as 0.5, not FS.
0.5.
I think it might be wrong.
No, just 1 minute. See here. First, what the Freebird diagram? So, what is the Freebird diagram of 5 kg block? Tell me first force. What is the first force?
So gravitational force
How much?
550.
50. Now, due to string, which force? Tensional force. Which direction?
Left side.
Correct. Next, this for now the spring at this point spring force will be there. Which direction spring force will be?
Towards the block.
Towards the block means here already it is in extension. Na? Already it is in
Yes, sir.
elongated state. That means
Yes,
which
sir,
direction
yes,
it
sir.
will be? Which direction it will be? See, initially it may be like this. The spring is maybe like this. This is the natural length.
So towards upside. I mean, matlab.
Correct. Correct. Towards along the spring upwards. Correct or not? See here. Correct. Okay.
Yes, sir.
Yes, sir.
This is the spring force. What about the direction? What is the angle? Which angle I have not given? Huh? Without
No,
angle, how you
sir.
have solved then?
Sir, that's what I
Sir,
was
that is
thinking
why I
how
told
to
it will be wrong.
resolve.
Sorry, I forgot to give angle 37 degrees. Okay. So now it is all into components. What are the components of spring force? Tell me. This side is what? Fs cos 37.
Cos
This side is what?
37.
Fs
Sin
sin
37.
37. Okay. Now is the block at rest or motion? They gave
Rest.
rest. Rest means in x direction and in y direction f net is what? 0. Tell me in x direction f net is 0. Tell me what are the forces x direction? T must be equal to what? Fs cos 37. In y direction? Fs sin
Fs
37.
sin 37 equals 50.
That's all. Now take this equation. Fs into sin 37 means what? 3 by 5 must be equal to 50. So Fs is equal to what? 5 into 50, 250 by 3. Now Fs is also equal to what? Today we learned spring force. What is the formula? K into
Delta X.
Delta X.
So what is K? 100.
100.
100 into delta X is equal to what? 250 by 3. So 0, 0. So this is 5 5s, 5 2s. So delta X is equal to how much? 5 by 6 meters. Now once you get delta X, you can get easily tension. Na? Now what is the formula for what is the equation here? Tension. T is equal to what? Fs into cos 37. Cos 37 is 4 by 5. Fs anyway we got as how much? 250 by 3 into 4 by 5. So 5 is 25. So that means 200 by 3 newtons. Is it clear?
Yes, sir.
Okay. Sorry,
Yes, sir.
I forgot to give angle and I asked you to solve. Okay, sorry. But you also, how you solved?
Sir,
How
I
you-
also don't know. I
how you
did
so-
2 is equal to 50 plus fs something and I did.
See, here Fs direction is in this direction, correct? In this direction means at what angle we should resolve, na? To resolve, we need angle. Okay.
Yes, sir, but I thought it is like
Ah.
that only we should solve. So I was thinking
Achha.
something else and doing.
Okay. So next one. Okay. So here, next problem. Can you do this as homework? Okay. So there is a ceiling like this. To this ceiling, there is a spring of spring constant 100, and the other end of the spring is connected to pulley, and on the pulley there is a string like this. Okay. To which 5 kg block is connected. Okay. Now block is at rest. Finally, what will happen? The spring will elongate or compress due to this weight of the block. What will happen?
Elongate, sir.
Correct. Okay. Initially, it is at natural length, but now it has got elongated. Are you understanding? Now it has got.
Yes, sir.
So what is the elongation? Take a screenshot and do it as homework. Steps is only one step. What is the step? Draw the free body diagram of 5 kg
5
block
kg block.
and draw the free body diagram of pulley. That's all. Can you do this as homework?
Yes, I will try.
Okay. So that's all for today. Okay. Any doubts in today's class?
Sir, not from today's class, but I have a question.
Oh,
So it is given in the worksheet that block B has mass M and it is released from rest when it is on the top of the wedge A. So diagram is needed. 1 minute.
which worksheet? The one which I gave?
Yes, sir, the recent one.
Means I have sent two things. First one is CRP, Newton's laws, classroom problems. Next one is assignment. One assignment I have sent for a normal reaction. You are talking about first one, huh?
Sir, you sent 2.
Just 1 minute. I'll show it.
Sir, I will show you the question otherwise.
How will you show?
Sir, I wrote it in my notebook. I'll turn on the camera.
Acha, 1 minute. Okay, show me. This is
Sir,
which.
this is the diagram.
Okay. What is the question? Show me the question.
Sir, block B has mass M and is released from the rest when it is on top of wedge A, which has mass 3M. So they're asking the tension in the chord CD.
Tension in the chord CD. Okay.
Yes, sir.
So how to do this problem? Now is this wedge moving or at rest?
Sir, they asked when to hold the wedge from moving while B is striking down A. B is moving, sir.
A is at rest.
So that is not mentioned.
This is based on relative motion actually, which is our next topic, constraint motion. Here
Okay.
this wedge is constrained. Okay, this problem I didn't give.
Sir, this was posted
Sir,
in
it
one
is
of the
there. Work sessions, 15th one, 8th question.
This is 15th question. Huh?
15th work session, 8th question.
Acha, work session number 15, 8th question. Huh?
Yes, sir.
Acha, maybe
Yes,
other
sir.
sir has posted. Maybe other sir has posted.
Sir, that we don't know who
We
posted.
don't know, sir. Who
Acha,
posted?
no, does that have what you call the friction problems also?
Sir, it was like they were mentioning it is with frictionless surface that way. And the
But
first problem was, I guess, with friction. So
Acha,
1 minute, I'm checking.
maybe that is an assignment of friction then, because sir has started friction. No? Another sir.
Sir, this is the first question. Two blocks A of 6 kgs and B of 4 kgs are placed in contact with each other. The coefficient of friction between B and ground is 0.5. A horizontal force F is applied on A. So find the minimum and the maximum values of F which can be applied so that the both blocks can move combinedly without any relative motion between them.
Correct. That is the friction. I think that assignment is the friction. Okay.
Sir, but that is only posted. Only one is posted for this time.
Acha, I think maybe I think sir is teaching friction chapter, na? So he has
Yes, sir.
given work session on that friction. Okay. Friction is next to Newton's laws actually.
Yes,
After
sir. Like
completing
for this exam, we are having Newton's laws only.
correct. After completing Newton's laws only, then you can understand fully that friction. Otherwise, it's very difficult. I mean, anyway, whatever has happened, okay. So means the assignment which I have given is this one. Okay, you are able
Sir,
to.
can you post this assignment because we did not get it, I believe.
Which one? This the one which I'm showing right now. This one.
So this one we have, Monica ma'am sent us.
This one only I'm explaining Newton's laws.
Okay. Okay.
By 1, 2, 3, 4. 4 I have finished.
Okay.
Now fifth problem. Now this is based on what you call heavy ropes. Find the acceleration, tension at 1/4 from right end. Okay, these are all
Sir,
what you call.
for the exam which we are coming, the questions will be this way, no only, sir.
Actually, frankly speaking with you, I did not give question paper actually. Frankly speaking, okay. So mostly I think they didn't ask me. So I think today is what, Friday or Saturday? Today is Saturday, no?
Yes, sir.
Today is Saturday. Maybe they may ask today, or if I will give questions on this one, or otherwise also if they have to give questions from Newton's laws, so they'll give from whatever I have covered only. Okay, if they give outside of what I have covered, then it will be bonus for you. Understood? Means
Yes, sir.
marks will be given to you if they are out of syllabus, because I have not covered. You understood?
Yes, sir. Yes, sir.
Suppose let us say this eighth problem is there which you have shown me just now. That is a constraint motion problem. Okay. In Newton's laws, our next topic we are going to see constraint motion. Are you understanding? Okay.
So, and so even many were there in that work session then. Like one more is a block of metal weighing 2 kgs is resting on a frictionless plane. It is struck by a jet releasing water at rate of 1 kg per second and at a speed of 5 meter per second. What is the acceleration? Initial acceleration.
So I think those things is very difficult to solve for you at this level. See right now, see your 18th question which I have given. You see, are you able to see on the screen?
Yes, sir.
This is my assignment only. So see here, block M slides down on frictionless incline as shown. The minimum friction coefficient so that M does not slide with respect to M would be. These type of problems, no, they come under relative motion and constraint motion. Constraint motion I have not explained to you. Are you understanding? Okay, so anyway, that assignment you cannot solve. Just follow this assignment which I'm giving. Okay, are you understanding?
Okay, sir. Yes, sir.
Yes, sir.
Or otherwise you ask sir to explain those problems. Understood? Okay, the other sir. Okay, because but concept has to be explained, no? Okay, one thing is what you call, either you ask sir to solve those all problems, or second thing is you just have to wait for what you call my completion of this topic, Newton's laws. My last topic is that one. See here, relative motion and constraint motion. See here. Did you see?
Yes, sir.
Yes, sir.
So they have given the assignment which should be given after this completion of this chapter. Okay. So anyway, no need to worry. I'll explain when that topic comes. I'll explain. Okay. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Okay. So today you just solve this homework. Okay. Today this one. Okay.
Yes, sir.
We'll meet next class. Okay. In the meantime, you can solve what you call not work session. You can solve objective books we have, na? You have what you call Arihant, DC Pandey. Which books you are having? Textbooks.
Sir, presently H.C. Verma is guide.
H.C. Verma. Then you can solve H.C. Verma. That is also good book. H.C.
Okay, sir.
Verma. H.C. Verma and booklets you solve. Okay. Is it clear? Okay.
Yes, sir.
Yes, sir.
Okay. So thank you all very much. We'll meet next week then.
Thank you, sir.
Thank you.
Thank you, sir.
In the meantime, this assignment which you got now, can you download that assignment or no?
Yes, sir, we can.
Then can you send it to my mail once or WhatsApp to my WhatsApp?
Yes, sir.
Okay, you have my number, no?
Yes,
okay.
Sir.
You can send it to my WhatsApp number.
Okay, sir. Yes.
After downloading, can you download these from your app, Ramanuja?
Yes, sir.
Vidya?
Yes, sir.
Yes, sir. Only after downloading it will open for you.
Okay. Then just send me to my what you call WhatsApp. Okay. Okay.
Yes, sir.
Okay.
Yes,
Thank
sir.
you very much.
Thank you, sir.
Thank you.